Okay, for now we want to represent our data. Vertical line graph. Let me just rub this off. For vertical line graph, I'm going to say vertical line graph. I'll also put my budget here. Okay, so this vertical line graph. Hello guys, welcome back to my channel, and to those who are new here, it's Laura here, and I'll be taking you through statistics. And today we'll be focusing on representing and summary of data. But before I go into that, I'd like to make some shout outs to those who always support me, and all to those who always comment. There is Beivin Maul, there is also Nyasha Maoma, there's my dad, Benjamin, there's my father, Benjamin, there's my, in my other shout outs, please kindly comment, subscribe, and I will definitely do so. I'll be focusing on representing summary of data, summary and representing and summary of data. Representing and summary of data. I'm going to go step by step into this process, and I will explain to you every bit of understanding how to represent and how to summarize your data in statistics. So today I'll be focusing on discrete data. Discrete data. Okay. Okay, so discrete data, it takes only exact values. Discrete data takes only exact values. For example, we can say someone is taking a survey, or yeah, a survey on cars, maybe cars that are passing through a toll gate station. It's a discrete number of values, yeah, that person will get, like the number of cars that will pass through the toll gate. It can be either 1, 2, 3 at a certain time. So it's discrete exact values. And also they can be shoe sizes. You can give examples of shoe sizes of children in a class. You can also be represented by their exact values. The number of tomatoes on each plant in a greenhouse. The number of tomatoes on each plant in a greenhouse. Like if you go on a single plant, there is no way you're going to get 9.5 tomatoes. No, they are going to be exact values of tomatoes. So you're saying discrete data takes exact values. Since I've said, for example, the number of cars, tomatoes, and etc. And also, discrete data is known as raw since they have not been ordered in any way. These values are not ordered in any way. They're not ordered in any way. For example, you can say I want to count the number of cars, of white colored cars that are passing through the target. That number, that survey is like that process cannot be exact. It's not ordered because as the cars pass through the target, they can be either white cars, silver cars, yellow cars, red cars. It's not, it's that's why we are referring to it as raw data. Okay. So for example, I'll give you an example. Okay, for an example, I have the number of snails in 30 quadrants. I've got 30 quadrants, each have got snails. So we are actually counting the number of snails in each quadrant. So these are the values or the number of snails in each quadrant. You can get 1, 2, 2, 3 in the second quadrant, 4 or 1, 0 or 2, 2, 3, 3, 2, 1, 0, 4, 1, 2, 1, 3, 2, 5, 0. Let me just continue my 5, 0, right? 2, 3, 2, 2, 3, 3, 2, 3. Okay, so these are the number of snails in each quadrant. In the first quadrant, you might find 1, the other you might find 2, the other you might find 2, 3, 4 in each quadrant, right? So these are the values. For these values, how do we then represent our data, or how do we then summarize our data? We then use a frequency distribution. We now use frequency distribution for discrete data, okay? We're now using frequency distribution for frequency distribution. Here we are using this to represent our data. So for frequency distribution, we count the number of times each value occurs. We count the number of values each value occurs. So we are going to say the number of snails. Let me use another color. We're going to say number of snails in each quadrant, right? And the frequency that the number occurs, the frequency, that is the number of times the number of snails, the same number of snails occurs. So we're going to make it into a table like this. Okay. So we identify the numbers that are occurring. We've got 1. It's kind of these numbers. These numbers are not exceeding 5, right? They are from 0 to 5. So I'm going to say the number of snails in each. They range from 0 to 5. 0, 1, 2, 3, 4, 5. Then now the second part is to determine the number of quadrants with 1 snail, with no snails, with 2 snails, with 5 snails, and so on. So the number of quadrants with no snails equals to 1, 2, 3. So here we come in, right? 3. Because the number of quadrants with 1 snail is 1, 2, 3, 4, 5 goes to 5. The number of quadrants with 2 snails, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 of them. And also the number of quadrants with 3 snails. We have 1, 2, 3, 4, 5, 6, 7. the number of quadrants with 4 snouts. So this is how it's done. You can see it's easy, right? And also the number of quadrants with 5 snouts is only 1 quadrant. Yeah, it's only 1 quadrant. So you have to make sure for you to know that you have done this right. The number, the frequency has to give you the total that will be mentioned. As I've said before that, we are going to count the number of, we are going to take snouts in each of the 30 quadrants. So your frequency should also add up to 30, right? So if we add 3 plus 5 plus 11, 7, 2, 1, it has to give us 30. Okay, now this is how we summarize the data, right? So for us to now represent the data, we are going to say use two ways. I'm going to use the vertical line graph and also the bar chart. Okay, I'm going to rub this off. It's no longer needed. Okay, so shows the number of snails. Number of snails. And also this bar chart shows the number, let's say number of snails. Now I will draw the graphs. It's very easy to draw these graphs. So you put your frequency on the y-axis. You put your frequency on the y-axis, the number of times it's occurring. Here also the frequency. Frequency, right? Frequency, please don't mind my spelling. Okay. So if you are following, this is how you should write it. Our frequency is this frequency. Then here we put the number of snails. The number of snails. Let me just go for short. Number of snails. Yes, also number of snails. Okay, so to draw this graph, hey, see that I didn't give the space for the numbers. Okay, so I'm going to say you just have to use the correct scale, nothing more. So for here, since it already has a what is it called?
What?
It has got already a proper scale. So I'm going to say 0, 1, 2, 3, 4, 5. So I will just do the same for this part also. Number of snails in this group. Up here, let me tilt mine. Okay. So the number of snails here, we also put 1, 2, 3, 4, 5. Now for the frequency part, we also have to use a proper, I don't know the right word to use, but we have to use in progressive, in orderly, okay, an orderly scale. I don't know. Okay, for this part, I'm going to say, what scale can I use here? Just to reach, I can use 2, or I can just use 1. 0, 2, 4, 6, 8. Now I'll just go for 2. 0, 2, 4, 6, 8, 10, then 12 here. The same for this one. I'll put 2, 4, 6, 8, 10, then 12 here. Okay, so to draw for a line graph, are we supposed to do? For a line graph, it only contains lines, guys. It only contains lines, and the lines have to emanate from your x values, right? So for the first one, 0, the frequency is 3. So this line is going to come from this point to it reaches this part, right? That's my line. For 1, it's going to come from 1, go for 1, and it reaches 5. Here, this is 5, right? Yeah. Okay, for 2, we're going to go for 11. Wow, yeah, it's like this. Yeah. Then 3, 7. 3, 7. Going to take it here as we approach our 3. 4, 2. Our 2 here. For 4. 5, 1. So my 1 is practically here. Then we go down. Okay, so that's how a line graph would look like. But what you can also do is, after using, because you'll be using a pencil, right? So you can rub this off. You can now rub this off. This will just helping you to guide you to, you have the proper points. These are really not really that much required. So you can, if you're using a graph paper, then it makes this easier. You don't have to use the dotted lines. You just use this. Okay, guys. So on bar graph, we draw our bar graph the same way as we did that one. Right. So for our bar graph, we are going to start with 0. So this is where my 0 is. Okay. Here it depends on the scale you're using. Some can even start, can put their 0 here. 0 for this, for y-axis, and 0 here. It just depends on the scale you're using. Meaning the line here, this line, will be now here for 1. Okay. So for the budget, I'm going to put the 0 here and the other 0 for the y-axis here. Okay, so it just depends on the scale you use. It doesn't matter the scale you use, just use any scale. So for this part, I'm going to say 0 is going to bring me 3. Yes, then 1, 5. Remember that for a budget, the bars are attached together. They are not separate. And also you have to know that they are also of the same size. Please don't mind the the the, the size of the graph that I'm producing. These bars should be of the same size. I could have used a ruler, guys, but since I don't have any, I'll just use, but they have to be the same size. I repeat, they have to be the same size. Okay, so for 3, we have 7, 7, 7. Yeah. Then for 4 we have 2. Please don't forget that they have to be of the same. Now I'm just trying to make them a bit narrow one. 5. So it's gonna come here. And okay, so hey, this one is quite a terrible one. I'll draw for you another one. I'll give you a picture that is a bit better than mine. But that's the whole picture. So you have to note that in the vertical line graph here, um, the graph has got distinct lines. They are distinct lines. You can see them. It has got distinct lines and also for the bar chart, the bars are all in this. They have to have the same width. As I said, they have to have the same width, and they are labeled in the middle of the bar on the horizontal axis. Let me just write this down. I'll just rub off my line graph here and try to show you what I'm saying. Important points to note and B. For my nota bene. Okay, guys, we are saying in the vertical line graph, the distinct lines reinforce the discrete the distinct line, they reinforce the discrete nature of variable. Right. Then in the bar chart, it is going to have the same width labeled in the middle of the bar on the horizontal axis. What do you mean by the bipart? You're saying 0, like the bar has to be on the middle, like the value like 0, 1, 2, you have to be on the middle of the bar, not here or here, but here, exactly at the middle. Okay, guys, moving on, we are going to focus on the mod. It doesn't really take time. The mod, we are saying the value that appears much. It is the value that appears much. On our graph, as we can see, the mod here would be our value 2. Because it has got the highest frequency. So the mod has got the highest frequency. This is our mod, and it's 2. Like there are the number of quadrants with 2 snails is 11. It's 11, here, not 12, right? So it's the one with the mod. That's for the mod part. So remember that the mod is the value that occurs much. So just summarizing what I've said, discrete values, they only take the exact values, guys. They only take the exact values. And We also know that the data is known as raw since they have not been ordered in any way, right? Then for drawing up or representing or summarizing the data obtained, you use a frequency distribution whereby you draw your frequency distribution graph, such as the vertical line graph or the bar chart. And also on bar charts, you have to remember that the bar charts have to have the same width and the labeling should be in the middle of the bar on the horizontal axis. And the mod is the one that is the value that appears much. Thank you guys. Do not forget to subscribe, like, and comment. And if you want to be named or called in my shoutouts the next video, please do subscribe, do comment, and I'll see you next time. Goodbye.